Oh boy, in this one, everybody, we're talking about speed. Oh, wait, here we go. No, sorry. So this video, we're talking about speed. So speed is similar to velocity, but it has a little bit more caveats to it. We'll also be talking about speeding up and slowing down. So position is just our regular position function. If we take the derivative, we get velocity, and then acceleration is our second derivative. Speed is the absolute value of velocity. So speed doesn't care about which direction the particle is talking about. So just remove the sign and then you have speed. However, if you're talking about is this thing speeding up or is the velocity increasing, what we need to do is we need to look at two things. Are velocity and acceleration the same thing? Then we would say that the object is speeding up or the velocity is increasing. If we're talking about slowing down or velocity is decreasing, then velocity and acceleration should have opposite signs. So let's look at some examples of this. So here's an example. We've got the graph of this is velocity now. We want to know when this particle is moving forward. So if it's forward, that means that our velocity is positive. So in this region right here, we have a positive velocity, so 0 to 1. And then 5 to 7 here, we have also positive velocity. The particle is moving backwards when we have negative velocity. So that's this big region down here. Note that I'm not using this part because in this region, we have no velocity. In order to talk about it speeding up, we need to make sure that the velocity and slope, because that's going to be the derivative of velocity, and derivative of velocity is acceleration. So we want to make sure that the slope and the velocity's value have the same sign. Velocity and acceleration are the same. So from 1 to 2, in this region, the slope is negative and the value of the velocity is also negative. These are all negative values down here. So here we would say that the particle is speeding up since the velocity and the slope have the same sign. Over here, we would say as well that the particle is speeding up because the value of the velocity and the slope of that velocity, acceleration, are both positive. The particle is going to be slowing down when the velocity's value and its acceleration are opposite sign. In this case, when is the slope an opposite sign? So here we have a negative slope, but a positive velocity because we have positive values here. So that would be where the particle is slowing down. Then we also have one from 3 to 5 because here our slope is positive, but the values of that velocity are negative. So they have opposite signs. That means the particle is slowing down. Then we also have one here where we have a negative slope, but a positive value for velocity. So negative acceleration, positive velocity. So our particle is also slowing down. So remember that acceleration piece that is talking about like what is the slope? Since this is a velocity graph, an acceleration is just talking about like what is going on with that second derivative. We don't have to match it up with velocity. So we have a positive acceleration we talked about from 3 to 6. Those were regions where the slope is positive. We have a negative slope right here. So we have a negative acceleration on this region because our slope is going down, and also a negative acceleration here. And we have acceleration of 0 when we have flat lines. So we have flat lines right here, and we have another flat line right here. Those are the 2 points where we have 0 acceleration. And then those negative accelerations are right here and right here. And then our positive acceleration is when our slope is positive because slope is derivative. Derivative of velocity gives us acceleration. If we want to know when the particle has its greatest speed, that is, now we're not talking about speeding up or slowing down, just when is its speed the greatest? Speed is, again, the absolute value of velocity. So when does this thing have its biggest value? I didn't label the y-axis on this, but this value is the same as this one. In the Finney book, they actually do it properly. So our greatest speed happens up here, and down here. I think they're both like -2 or something. So those are the biggest values that we get out of velocity. One of them is negative, one of them is positive, but speed doesn't care about sign. When we're standing still is not about speed. That just means that the velocity is zero. Velocity, standing still, velocity is zero. More than an instant. So like right here where our velocity is zero does not count because they want more than an instant. So that would be in this goofy little region over here. It's not here because that was where our acceleration was constant. So we're just not accelerating anymore. So the only point where we're standing still is when the velocity is constantly zero. Yes, our velocity is constant here, but it is not at zero. It's constant at like a -2. Here's another example looking at speeding up and slowing down. So I was given this position function, so I figured out what my velocity and acceleration ones were by finding the derivative, and I graphed them on my graphing calculator. I want to figure out when we're speeding up and slowing down, so I need to see when these values are not matching the sign of these values. So to talk about when it is the speed increasing, when are we speeding up, we need to make sure that the sign of this thing is matching the sign of this thing. So at the start, velocity is positive and acceleration is negative. So that is not speed increasing. However, at this point to here, then we have a negative velocity and we have a negative acceleration. So that is where the speed is increasing. So I just did 0 here and 0 here, and I got these two values. Then once this crosses the x-axis, then this is positive and the acceleration is positive. So that is at 3.18. The place where we're decreasing is where they are opposite signs. So as I stated before, right here, we have a positive velocity, but a negative acceleration. So that is going to be where we are slowing down. And then in this region right here, velocity is negative, but acceleration is positive. So that is where our particle is slowing down. If they have opposite signs, then they are slowing down. If velocity and acceleration have the same sign, our speed is increasing. If we're talking about things changing directions is just talking about when the velocity is swapping from positive to negative. It has nothing to do with speed. So we can tell that that happens at these 2 points and see when the velocity changes from positive to negative. If we are talking about at rest has nothing to do with speed because at rest means that the velocity is 0. And if you're taking the absolute value of 0, it's still 0. So you don't have to worry about speed for at rest. It's just asking when is the velocity equal to 0. And those are at those same 2 points that we've kind of been talking about where the velocity hits the x-axis. That is the end of our video on talking about speed. So a reminder that speed is just the absolute value of velocity. The trickier part talking about speed is like the speeding up or slowing down. You have to take a look at the signs of both velocity and acceleration. If they have the same sign, then we are speeding up. If velocity and acceleration have different signs, then we are slowing down. Speed being the absolute value of velocity. But if you're talking about speeding up and slowing down, you have to do this comparison thing. Thanks for watching. Have a speedy day. Zoom.